product rule of exponents says if m and n are positive integers and a is a real number, then a to the m times a to the n equals a to the m plus n. This says if you are multiplying the same base A, then what you can do is keep that base and add the exponents together. And we can see how that works if we're multiplying 2 squared times 2 to the third. So we know that 2 squared is 4, and 2 to the third, 2 times 2 times 2 is 8. So that's 32. And we can see that this would be the same thing if we use the product rule to add the exponents together. So 2 to the 2 plus 3 is 2 to the 5, which is 32. So this is how the product rule works. Let's use this product rule to simplify some examples here. The first example, 3 squared times 3 to the fourth. We're multiplying the same base, 3, so we keep that base, and add the exponents, 2 plus 4, which is 6. And it's a number base, so we can actually multiply this out. 3 times 3 times 3, 6 times. Okay. And I'm just going to put that in a calculator. When we multiply those all together, we get 729. Our second example, x to the fourth times x to the fifth. We're multiplying the same base, x. So we will have that base and add the exponents together, 4 plus 5, which is 9. I can't evaluate this exponential expression because I don't know what the base x is. It's variable. Our third example, we're multiplying the same base, z, and whether we do it 2 times, 3 times, 4 times, however many times you multiply base z, we can still use this product rule. So keep that base and add the exponents together. 3 plus 2 plus 5. So that's 5 plus 5, which is 10. And the last example, 3y squared times negative 4y to the fourth. Let's multiply the number factors first. We can commute and associate those factors, and then multiply the base y factors. Okay, so 3 times negative 4 is negative 12. And y squared times y to the fourth, we're multiplying the same base y, so add the exponents. And that'll give us y to the sixth. If you have a variable without an exponent, like x, we assume that that exponent is a 1, meaning you only have one factor of x. And another example with the number 4. 4 to the 1 is 4, right? There's only one factor of that base. So no exponent, the exponent is 1. Let's take a look at these different expressions and pay close attention to where the parenthesis is to decide what the base of the exponent is, okay? So our first example, negative 3 squared. The exponent is touching the parenthesis. So inside the parenthesis is the base. So the base is negative 3. And when we multiply that together, that's a positive 9. For the second example, the exponent is only touching the 3. So 3 is the base here. The negative just stays in front. So we have the negative of 3 times 3, which is 9. So that makes it a negative 9. For our last example here, 5 times x squared, the exponent is touching the x. So the base is x. And we really can't do anything to simplify that. Technically, 5 also has an exponent, so 5 could be another base with an exponent of 1.